Welcome to The Explainer. Today we're diving into a seriously thrilling technological frontier. We already know how incredibly powerful digital AI is, right? Well, today we're looking at the next massive leap, the exact moment all that intelligence takes physical form in the real world.
For years, generative AI has been, sort of stuck inside a two-dimensional digital chat box. But right now, a huge pivot is underway. We are finally asking the big question. What actually happens when AI leaves the chat and starts interacting with the physical world all around us?
Okay, so let's start with a quick definition. Physical AI, which is also known as embodied AI, refers to machines that can sense, reason, and act to manipulate their environment. And to be clear, we're not just talking about a robot vacuum blindly bumping into your couch here. We are talking about highly advanced humanoid robots and smart manufacturing ecosystems that genuinely learn and adapt on the fly.
Here is our roadmap for today's explainer. 1. AI leaves the chat. 2. The AI capability evolution. 3. Tech powering the shift. 4. The US market leaders. And finally, number 5, a trillion-dollar future. Let's jump right in.
Part 1. AI leaves the chat.
Instead of just generating code or writing emails, these early applications are out there delivering massive, real-world productivity gains. How? By tackling the dirty, dangerous, or just incredibly repetitive tasks in industrial operations. By deploying machines that can literally see and react to real-time changes on warehouse floors and logistics hubs, we're moving way beyond basic blind automation straight into true intelligent autonomy.
Moving on to Part 2, the AI capability evolution.
This formalized jump from generative to physical AI is perfectly mapped out by Bank of America Global Research. Just look at the progression here. We started with basic expert systems, moved into machine learning, and then, of course, rode the huge generative AI boom. This leap to physical AI essentially compounds all those previous breakthroughs. It takes better models, richer data, and massive compute power, and finally allows intelligence to operate safely outside of a server farm.
So, the fundamental shift here is the move away from explicit programming. Think about it. In the past, if you wanted a robot to pick up an apple, a human programmer had to painstakingly hard-code every single angle, grip pressure, and motor movement. If that apple moved even an inch, the whole thing failed. But now, with end-to-end AI, the machine uses trial and error and continuous feedback to figure it out itself. It experiments and refines its approach organically, just like we do.
Which brings us to Part 3, tech powering the shift.
This kind of autonomy is happening right now, and it's all thanks to a convergence of some pretty incredible tech. First off, you've got vision language models giving the AI its perception. Next, vision language action models step in to translate that perception into actual physical movement. But here's the really crazy part. When you add in world models, the AI can simulate outcomes in 3D. It can literally reason about physics before it even makes a single move. Mind-blowing, right?
And, as NVIDIA CEO Jensen Huang points out, open models are accelerating every single stage of this pipeline. This open-source innovation is an absolute game-changer. It means developers don't have to spend millions building a foundation model from scratch just to teach a factory robot how to sort boxes. They can simply grab the community's tools, fine-tune them, and deploy them incredibly fast.
All right, let's look at the players in Part 4, the US market leaders.
It actually really helps to think of this hardware value chain as a living organism. The platforms service the brain. The edge computing acts as the nervous system, and the sensors, those are the eyes. And if any one of these pieces lags in performance, the entire physical AI system falls apart. Let's break down the key companies dominating each of these vital roles.
Starting with the brain, NVIDIA is pretty much the undisputed leader in training infrastructure right now, especially with its GROOT foundation model and Cosmos engine. Meanwhile, Tesla is aggressively pushing this brain out into the real world. Their full self-driving and the Optimus humanoid robot represent some of the most ambitious, aggressive deployments of physical AI happening anywhere today. But think about this. What happens if a self-driving car or an autonomous drone suddenly loses its internet connection? It can't just stop thinking, right? That's exactly where the nervous system comes in. Companies like AMD and Qualcomm design high-performance edge chips so these machines can make split-second life-or-death decisions locally. And providing the eyes, companies like Ouster and Aurora are supplying the critical LiDAR and 3D sensing tech, making sure these systems can safely navigate highly unpredictable human environments.
And finally, Part 5, a trillion-dollar future.
Institutional capital is absolutely flooding into this space.
We are looking at a projected multi-trillion-dollar opportunity over the next decade. Researchers and investors are clearly viewing this as the next great global growth engine. Because, guys, this isn't just about making a slightly better software tool. This is about completely rewiring mobility, industrial fulfillment, and physical labor across the entire globe.
So I'll leave you with this thought to ponder as we stand right on the brink of an era shared with adaptable, autonomous machines. What happens to our world when digital intelligence becomes a permanent physical fixture in our daily lives? The leap from chatbots to physical AI is no longer science fiction. The infrastructure is built, the models are converging, and the rollout has officially begun. Thank you so much for joining me for this explainer, and definitely keep your eyes on the physical spaces around you, because very soon the intelligence we interact with won't just be trapped behind a screen.